Welcome back. I am debugging a circuit I designed today, which we'll cover in a future video. But I was using a logic probe and thought it might be interesting to share with you what a logic probe is and how it can be used to analyze digital circuits. So with that, if you're interested, let's head over to the lab bench and I'll show you how to use a logic probe. And one of the great things to use while you debug a digital circuit is a logic probe. Basically, all it does is light up and make a sound based on a high or low signal. So what you do is, let me put the schematic off to the side here. This is the circuit I'm actually working on. Let me clear some space here. And what I'm going to do is I've got 5 volts coming out of my supply. I'm going to set up my ground and my 5-volt line. So now the circuit's actually on. I've got a little LED. I don't know if you can see it or not. But somewhere there's the LED that lights up. Yeah, you just saw it. I'm trying to get this all centered up. Then what you do is you take your logic probe. This one has both a TTL and a CMOS setting. It also has pulse or memory. You want to put it on the exact same 5-volt line as your circuit. I'll put the other ground over here on this side, make sure it's connected. In this case, I'm using 5 volts as high. So if I go to the high line, let's make sure we got it connected. Sometimes it doesn't connect to the ground. Okay, let's see. Okay, there we go. So that's the low sound. That's high. High, low, high. So now what you can do with this is by looking at your schematic where you're expecting certain signal behavior, let's say on the push of a button, you can actually touch this directly on your microprocessor pin or on a point that you're in question of whether you've wired it correctly or if it's behaving correctly. A perfect example, I was using a Nano, an Arduino Nano, and I was trying to use A6 and A7. I think it was A6 as an output. And I actually learned that A6 and A7 on a Nano can only be used as inputs. So I did not know that before. I was able to figure that out. I confirmed it online with what I was seeing, trying to determine whether the Nano was broken or not, and lo and behold, I learned something new, which is what we all shoot for every day, I think. So if we look at this, like I have a number of buttons on the front that you can't really see, but let me look at the circuit here real quick, because I already solved the problem I was trying to fix earlier with the logic probe. But let's see what we got. So if I press that button, it should be going to D2 and it looks like it should go high. So let me get my glasses on. Find D2 on the back here. That should be D2. It's low now, and if I press it, there we go. So there's the ground line. That's the D2 of the Nano, and then when I press the button, I pull it high, you can hear that it's actually working. So depending upon the kind of circuit you're actually designing, this can be really quick and much faster than a volt-ohm meter or a digital multimeter. Anyway, checking the voltage. You can also check the voltage if you don't have a logic probe. But a logic probe makes it quick and easy because you can actually listen to each of the bits or each of the signals that you're trying to listen to. TTL and CMOS, the low I think is 1/3 of the voltage in. TTL, it's like what, 2.5 volts or something like that. So the settings allow you to adjust where a high and a low would be depending on the type of circuitry. So that's it. That's all there is to this. The original one I had was from Radio Shack from when I was a teenager. It was this gray, boxy looking one, very rectangular. I just got this one off of Amazon. So far I'm happy with it. It does what I need it to do, and it makes life a little bit easier when I'm debugging circuits. So, anyway, hope that was helpful. If you have any questions, suggestion for future videos, post them down below. If you want to subscribe, great, and if you don't want to, that's okay too. All right, thank you guys very much.